numbering. The IPC nomenclature system. Concept by solving the examples. I am now satisfying the valency by placing the hydrogen atoms here. So in this case, we should first, that means longest continuous carbon chain selection chain, then the carbon atom of the alkyl group or the carbon atom of the longest continuous carbon chain will give minimum, cannot give minimum locant to this alkyl group, but if we will number side, the numbering will means be, but the which the way the minimum locant rule though not followed, so it will be wrong. So the IPSC name of this compound will be, first I have told in the recorded class that we should place the name first and then will be given property. That substitution group because it one carbon chain and occupied the position of hydrogen. That means here the hydrogen is replaced by the alkyl group which has the general formula CnH2n plus 1, CnH2n plus 1, CnH2n plus 1, or the alkyl group formula will be CH3. As I have told, the alkyl group has a suffix that is YL. Alkyl group has a suffix word root. So single carbon is expressed by the word root that is meth. Here the suffix alkyl group so the name will be methyl. For this substitution methyl, name will be methyl, and the longest continuous carbon chain contains 4 carbon. So the name of the compound will be, I have told, first we need to place the name of the substitution group with the locant name, so the locant here is 2 and the name of the substitution group is methyl, so the name becomes 2-methyl, and the straight chain organic compound has the name according to the organic compound that which satisfies, it is the derivative of alkane, so it becomes but because 4 carbon are present and single due to presence of alkane or due to derivative of alkane, the name becomes 2-methyl butane. 2-methyl butane. Next questions. So I am two substitution group. Only I am using the hydrocarbon concept here. Next, I have placed CH3. So in this case, the sum of locant rule, in this case, sum of locant rule gets followed. Sum of locant rule gets followed. That means if a longest continuous carbon chain contains more than one substitution group, then the sum of their locants should be minimum. How can we decide if long continuous carbon chain contains more than one substituting group, if the carbon chain two of substitution group, that means here two branches are present minimum and the next two branches are here, so there are four ends in this carbon chain. So two substitution, if we change in this case, the longest chain will be 1 2 3 4 5, 1 2 3 4 5, 1 2 3 1 2 3 4. So the longest continuous carbon chain will be 5. So if you start from this side, 1 2 3 5, in this case right side to left side, that means 2 3 4, and in case of right side to left side, the locands are 2 and 3, 2 and 3. So the sum of locants says the minimum sum of locands in a long continuous carbon chain is the accurate chain carbon chain selection. Then we can move for nomenclature system. That means here is the correct carbon chain numbering and it is the wrong carbon chain numbering. So if we will move for nomenclature, then what will be the nomenclature system? So in this case, in this case 5 carbons are in the quantity group and all single bonds are present, and so the name of the main chain or the straight chain or long chain carbon will be expressed with the pen as 5 carbon are expressed and single bond are represented by the it contains two substitution groups which are identical to each other and it satisfies the alkyl group formula. So here methyl is present, here another methyl is present. So if we have two mango, we says two mangoes. Similarly, if here two alkyl group which is a methyl group, so two methyl groups are present. So we can say the 2 and 3 position are occupied by the methyl group. So I am placing 2 position and 3 position as the locands are expressed before the name of the substitution group. So the name of the substitution group are expressed just before the name of the substitution group are expressed just after the locands. So the locands are expressed 2 and 3 and 2 methyl groups are present. So I have written methyl, but if I will write methyl, it will be wrong because there are two locands and there is no single methyl group is present. So there is 2 methyl group. So I am writing dimethyl. So the proper nomenclature for this compound will be 2,3 dimethyl pentane. If two similar similar groups are present, then it is expressed by the term or numerical term tetra carbon pentaxide, the 5 carbon. Similarly, identical substitution groups are expressed by different numerical terms. Okay, next we will go for some functional groups presenting in a longest continuous carbon chain. I am writing here 1 2 3 bulky alkyl group. I have told bulky alkyl group, new term, bulky alkyl group. Is a bulky alkyl group, I will tell bulky alkyl group. Okay, next I am satisfying the valency of this carbon chain. Here satisfied, I am placing here is 3 are present. In this case, we have to decide if a carbon chain contains other atom than carbon and hydrogen, then that may be a functional group. Here the functional group is carboxylic acid COOH. If a functional group is present and it is monovalent and contains carbon atom, I have told, then the number 1 position should always start from the carbon atom of the monovalent functional group. That means the number 1 position will always start from the carbon atom of the functional group of carboxylic acid. That means the number 1 position will start from here, and then it will progress towards any direction to find out the longest continuous carbon chain. That means if you reach here, we have two directions. That means we have to move from forward direction, we have to move to forward direction, and we have direction. What will be the correct direction for longest carbon chain selection? So in this case, we can go to downward direction. Downward direction, the longest continuous carbon chain will contain only 4 carbon. But if you use continuous carbon chain rule, the chain selection will progress to this direction, and numbering also follows this rule. So we will number to this direction. That means it is the accurate chain selection rule is followed in this case. So I have selected longest continuous carbon chain. I have written it as the formula CnH2n plus 1. I have told number of times. In this case, if I will put here 2, so the value of the alkyl group becomes C2H5. In this case, if the alkyl group contains more than 1 carbon and expressed in a value 3 becomes C3H7, it is called as a alkyl group. So before selection, if a carbon chain contains more, that means it should be opened before carbon chain selection. But we can say that we can easily identify that here 3 carbons are present though it is open, but here 2 carbons are present though it is condensed, it is present in bulky form. But before chain selection, the rule says that it should be opened. That means it should be opened means 2 carbons are here, chain selection after the chain and not chain, we can go for nomenclature. That in this case, I know I told that acid has the IPAC name, that is alkanoic acid. Alkanoic acid. So alkanoic is the suffix for carboxylic acid. So if a carbon chain contains carboxylic acid, then the name will be 5 carbon. According to 5 carbon, the name of the main chain will be penned, because the 5 carbon always express the 5 number of carbon present in the longest carbon chain. Will be canoic acid. Acid or IPAC nomenclature for carboxylic acid, the name of the compound chain will be canoic acid. If you will conclude that it is the complete nomenclature for this system, that will be wrong. Because this number 2 position has the suffix YL. So here 2 carbon are present, so the name becomes eth, and due to presence of alkyl group, the suffix is YL. So I have to written ethyl, and the ethyl is present in 2 position, so the locand is 2. So the name becomes 2-ethyl pentanoic acid. 2-ethyl pentanoic acid. Okay, next we will go for, I have told the substitution group as alkyl group, the functional group with alkyl group, and we will go next for the 2 functional groups. If present, then the priority rule. So you will use now the priority rule with one example. Now I am satisfying the valency of the hydrocarbon chain. In this case, we have to decide the first the functional group before going for carbon. Functional groups has the seniority and juniority order, that means priority order. In this case, the aldehyde is the senior functional group, so the aldehyde functional group should always given priority before the haloalkane group, that means chlorine group, or halogen group, that means chlorine group. So the number one position always start from the carbon atom of the aldehyde carbon, that means the number one position start from the carbon atom of aldehyde, as it contains carbon atom and it the senior functional group. So number one position start from here, then move to the carbon atom of the functional group. Then we have two. We can move to this side or move to this side. If we will move to this side, then the carbon chain may get wrong. I am decreasing the carbon number here. We will go for next. We will go for long carbon chain. Now decreasing carbon number means here we can go for 3. Here we can go for 3. That means if we will go for 3, this functional group may get neglected. So I am going for this side. That means in this case the junior functional group gets minimum number, but the senior functional group as contains carbon atom gets the number. That means here that which is the alkyl group. The priority rule gets followed. That means here the meth means methyl group are present, and here the another substituent group is chlorine. In this case, we use the prefix for the junior functional group, and the chlorine has the prefix chloro. So the senior functional group occupies the name of the main chain, that is the senior functional group here is 3 carbon has a word root, that means prop, and according to word root, if you will use this word root in this format, so the name will be alkane means propane, and the E will be replaced by the L, so the name becomes propanol. And the 3 carbon contains chlorine to the second carbon, or directly bonded to second carbon, and chlorine group is present to the directly present to the near to the third carbon, so it becomes 2 chloro 3 chloro 2 methyl. But according to alphabetical rule, that means the alphabet rule will be followed. C comes first, so the position for the substituent groups will be methyl 3. The main carbon are expressed by the term prop, so the name becomes. So write here. So I am writing question for continuous carbon chain, long continuous carbon chain. I am writing here. I am satisfying the valency of the hydrogen. In this case, group, then we should follow the rule according to the functional group. Here the divalent functional group ketone is present, so it is the alkyl group side, it is the alkyl group side. In this case, if we will count the carbon chain from this side, then the functional group carbon will occupy the 4th position, but if we will move from this side, the functional group carbon will occupy the 3rd position. So the correct sequence rule says that the carbon atom of the functional group should always get minimum number if it is a divalent continuous carbon chain producing capacity. So in this case, if we should number from this side to give minimum locant to the functional group carbon. In this case, if we will move to this side, so the carbon atom will occupy 3 position according to rule or IPSC rule. Ketone has the IPSC name alkanone, always possessed by a locant. That means in this case 6 carbons are present, so the name becomes, or word root for the 6th carbon is hex, and the locand for ketone is 3. So I am writing for locand I have written 3, and for the carbon word root I have written 6. So hex, and due to ketone it becomes hexanon. Hexanon or hex 3-ONE. 3-hexanon or hex 3-ONE becomes the name of long continuous carbon chain, producing discontinuous carbon chain. Let's start. I have satisfied the valency of the carbon. It is the functional group for ester. First, everyone should decide the functional group before going for chain selection, chain numbering and nomenclature. So, it is the functional group for ester. That means RCOR is the functional group, or the general. It is the COO is the functional group and RCOR is the general formula for ester. In this case, ester produces discontinuous carbon chain, and ester has the IPC name alkyl alkanoate. Alkyl alkanoate. So from the name from the name of the IPC name of the ester we can conclude that it contains two words. Why two words? Because it is a discontinuous carbon chain. One carbon chain end is expressed by alkyl and another carbon chain end is expressed by alkanoate. Which carbon chain is expressed by alkanoate? That carbon chain is expressed by alkanoate which contains the carbon atom of the functional group. What I have told? Any carbon chain end or the alkyl group part which contains the carbon atom of the functional group is included under alkanoate. Which alkyl group part will be included? The alkyl group which contains maximum number of carbon. Maximum number of carbon will be counted along with the carbon atom of the functional group and will be included in the alkanoate section, and the alkyl group section which contain minimum number of carbon will be included under alkyl group. That means if we will do opening of the structure, then the opening will be like this, and it will be discontinued due to presence of the chain will be discontinued due to presence of oxygen atom. So in this case the carbon of the functional group is counted. For 4 carbon the names become butanoate. I have told alkanoate will be included to that side which contains the carbon atom of the functional group along with the carbon of the alkyl group, and alkyl group contains minimum number of carbon, so the name becomes ethyl, and it contains 4 carbon, so it will be ethyl butanoate. Ethyl butanoate. So I have practiced you. You should practice some questions in the coming class, in coming time on IPC nomenclature. Thank you.